Stan Gibilisco here, proprietor and operator of amateur radio station W1, GV, Whiskey 1, Good Vibrations. Here to talk about a subject that you may have read about in any of the ARRL publications or antenna design publications, but I'd like to talk about antenna feed line resonances at high frequencies, that is in the bands. I'll include 160 meters in there, but generally 80 through 10 meters. Here's an example of an antenna. It could be any kind of antenna, vertical, ground plane, Yagi, any kind of antenna, and here's your feed line. It could again be any kind of feed line, parallel wire, coaxial. I don't really know what other kinds are commonly used at HF. Single wire occasionally in certain Windham antennas, but what you want to avoid, and here's the length L of your feed line from the feed point where the feed line meets the antenna to the radio or the output of your transmatch or whatever. You measure the length of this feed line with a tape measure or whatever overall, and that is your length L. What you want to avoid is any length of L that is a quarter wavelength or any integral multiple thereof, so that it is not quarter wavelength resonant or resonant on any harmonic thereof, so that it minimizes the possibility that this feed line will act as an antenna and develop what is known as antenna currents, which can cause that dreaded phenomenon RF in the shack. When you calculate this length, or rather the lengths that you want to avoid, you should always use the formula that you would use as if it were a single wire. That is, for a quarter wavelength, the frequency equals 234 divided by, pardon me, I'm getting a little bit ahead of myself here. Not the frequency. The length equals 234 divided by the frequency. I'm getting all confused as usual. The length you want to avoid is 234 divided by the frequency. That's right. And this is a length in feet. You want to avoid this length for your transmission line L or any integral multiple thereof. So, for example, let's just take an example. Let's say that you want to design an antenna for a frequency of, say, 7.1 megahertz. Well, let's say you're a hardcore CW man or woman, and you want to have an operation at a frequency of 7.030 megahertz. To calculate the length, you divide 234 divided by 7.03. 33.28 blobbity 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 blah. You do not want to have a feed line that is that particular length. Now, this what I have here, have drawn here, is a number line going all the way from 0 feet to 160 feet, so you can plot lengths to avoid very conveniently, and 33 feet is one of those lengths. 33 feet, approximately there. Avoid that. Then you want to multiply this length times 2, 66.6 feet roughly. You want to avoid then There's 70 right there. Let's say something right about. Want to avoid that. Okay, let's divide that by 2 again. And multiply now by 3. 99.8 feet, that's just about right on the nose at 100. So it's about 33 and a half, maybe 67 and 100. And then, of course, you just repeat that all over again indefinitely. You want to avoid these lengths because they could be resonant, and the radiation from your antenna could resonate with your feed line and cause your feed line to act like an antenna at 7.030 megahertz, even whether it be coaxial cable, open wire, or single wire. You don't want your feed line to act as an antenna. You want your feed line to transmit your signal from your radio to your antenna. You don't want your feed line to radiate, and you don't want your feed line to pick up anything from the outside. You want to avoid this because these currents can again produce that. And I hate that, especially at high power. It can cause all your devices in your station to go crazy, particularly that little thing between your ears known as gray matter. In my case, about the size of a walnut, protected on all sides by 3 inches of solid bone. But unfortunately, RF gets right through that bone and drives that brain crazy. If you run QRP, you're very lucky indeed, because you're not likely to see RF in the shack in any case, but you will still nevertheless have the radiation from the feed line that you don't want and the pickup of signals in the feed line that you don't want at any power level. Whether it discombobulates your equipment or not, it degrades the performance of the antenna because any signal radiated by the feed line can't be radiated by the antenna because it never gets there. Any signal intercepted by the feed line can compete with anything that is intercepted by the antenna, and if you're using a directional antenna like a Yagi or a quad, bad news. Lucky are you indeed if you have the real estate, the hardware, and the dough to create a Yagi or quad for this frequency. But ideal lengths then would be midway between all of these points. Right here, say, right there, right there, right there, as far away from that resonance as you can possibly get. Those are ideal lengths. Looks like here something around 17 feet, maybe something here around 55 feet, something here maybe 85 feet, 115 feet, and things like that. Those are ideal lengths for the feed line at this frequency. Now, if you're going to make a multi-band antenna, you're going to grossly complicate your situation. It's going to make things more difficult for you. Let's say that you also want to use this antenna on 20 meters at, say, 14.030 megahertz. Dual band antenna. Well, you're going to have pretty close to these points right here. And you're also going to have all of the values in between, right midway in between. The ones that were ideal before are now going to be verboten. You can use a calculator and figure this out. 14.030. Let's see. 234 divided by 14.030 equals 16.67, or about 16 2/3. Let's just call it 16.67, shall we? If you add 16.67 to that, 33.34, or right about here. Then you add, again, 16.67. About 50 feet, right about there. So all these lengths are bad ones to have for a dual band antenna, or for an antenna intended only for that frequency. I'm allowing a little bit of margin for error here, because 14.030 is not exactly twice 7.030, but it's pretty close. So now your ideal lengths would be anything midway between these red marker thingies. You want to stay away from any length L that is an integral multiple of a quarter wavelength electrically treated as a single wire at any of your operating frequencies. And of course, if you have a real one of those 5-band antennas and things like that, you've got quite a conundrum on your hands. There are ways to choke off antenna currents on a feed line, and you're probably going to have to resort to one of those, such as the installation of ferrite beads at various points on your feed line, or various little coils. Wind your feed line up into little multi-turn coils to create chokes at periodic intervals on your feed line. Or you can just do nothing at all, let everything go to chance, and when you get burned off of the chassis of your radio, or you start calling CQ into a metal microphone, and it goes something like this: CQ, CQ, CQ. Oh my God. Don't come running and crying to W1GV. Now saying 73, which means best regards. I guess could also mean lots of luck. And so long, which in my native tongue, fist, would mean that you'd get burned off the key when you send da-da-da-da-da-da.